Hello, Miss Simmer here. Welcome back to Geometry on YouTube. We've got section 12.3, Inscribed Angles. Inscribed angles can be a little tricky because there are so many different inscribed angles that can appear in a circle, and you can have so many lines in a circle to distract you from finding that angle. But I'm going to give you some hints and tips. First, explaining what an inscribed angle is. Well, an inscribed angle is pictured here. Let me get this arrow out of the way for just a second, and then I'll put it back in. Our inscribed angle is formed by 3 points on the circle. 3 points on the circle. So it can't go partially on the circle. It can't do this. You can't hit the center, then a point on the circle, and another one. That would not be an inscribed angle because it has to hit 1, 2, 3 points on the circle. Another definition of it would be an angle made of 2 chords. AC is a chord, BC is a chord. Here, this would be a radius and a chord, so it would not follow that definition. You can certainly follow along by reading your textbook. That gives you your definitions, because I'm not going to write them out on the board. But you could also print up the notes in this section of your materials in my math lab. So this is your inscribed angle right here. Angle C is the inscribed angle. Now, we call AB, the arc, the intercepted arc. Just like somebody might intercept or catch a football or intercept a pass, the intercepted arc is caught or between those 2 chords or the rays of the circle. Now, they're not drawn as rays, but we imagine them as continuing as rays, and it doesn't matter if they're drawn as a ray or not, it is an angle. Now, the first theorem or rule that we have to follow is different from central angles. Central angles and their intercepted arcs were identical. They had the same degree measure, so it was pretty simple. Up here, the arc AC, notice on this side, and the angle B, well, angle B is half of the arc. So the arc is twice as much as the angle. So here, if AC is 100, then the angle would be 50, half as much. Here's another example from our notes. If we're looking for angle B here, our intercepted inscribed angle, we look at our intercepted arc, 124, we take half of that, and our angle would be 62 for angle B degrees. Conversely, that means, of course, the opposite way. We knew that from previous chapters. If we're looking for AC and angle B is 42, the arc would be twice as much, 84, for that arc. So the way that I remember it is the pointy end is small and the opening gets larger and larger. So your larger number is toward the opening, and the smaller number is toward the point. So you can remember that the angle will always be half of the arc. All right, moving on. We're going to use inscribed angles throughout this whole section, but you're going to see it in multiple ways. So we have 3 corollaries we want to do. And then we'll return to multiple examples where we use just your basic inscribed angle that we went over, and then lots of different versions of that inscribed angle. So starting with our first corollary. Our first corollary says, hey, what if we have 2 angles and they open up to exactly the same arc? So we have angle, let's do A and B, like the notes, A and B. I sort of jump to the second page of the notes to the corollaries and then go back and do a bunch of the examples if you're following in the notes. So we're looking for angle A and angle B. Well, the arc here is the same for both. A opens up to that arc, B opens up to that arc. So the rule is if they have the same arc, the angles are congruent. So the measure of angle A is equal to the measure of angle B. All right, the second corollary says, what if we have a diameter and an inscribed angle opens up to the diameter? Well, we know that this is half of a circle. It's 180 degrees. So its arc is 180 degrees all the way around. So what would its angle automatically be? Half of that, because the angle is half of the arc, 90 degrees. So that's our second corollary. Now our third corollary gets a little fancier because it's got 4 different inscribed angles. This is a quadrilateral. Doesn't have to be a square or a rectangle or a trapezoid. It can be any quadrilateral. And this one gets a little fancier. So you have to follow along a little bit. Now, in this particular case, keep in mind, if I say, hey, I want to find inscribed angle A. Well, inscribed angle A, we would need half of its arc. Its arc is here, all the way around from B to D. Just look where this chord goes and where that chord goes. Okay, well, look at angle C, which is opposite it. Its arc goes from D all the way around to B, where this chord is. So notice angle A and C, if you put their intercepted arcs together, you have the whole circle. So if the arcs add up to 360, then the 2 angles together are half of that, or 180. So that means this is a sum of 180, or they're supplementary. Does that work for B and D? It sure does. So what we can summarize that as is the measure of angle A plus the measure of angle C adds up to 180. They're supplementary. And the measure of angle B plus the measure of angle D, also supplementary, adds up to 180 degrees. All right, so let's do some problem solving with inscribed angles and these 3 corollaries. Okay, so sort of going back to a couple of examples from the beginning of these notes. This is back at example 1, but B. We've got this angle, and they have E, H, G. They're asking for what is the measure of arc EFG? Well, let's look at EFG. Excuse me, I wasn't supposed to put that there. All right, this is supposed to be here. Okay. So, picture as it's given, I highlighted the arc EFG. And now we're looking for its measure. Well, if we follow this point, the end of this arc, back, we get to point H. If we follow this chord back, and this chord back, we get to H. So H is the inscribed angle. EFG is the intercepted arc. So if the angle is 90, the arc is twice as much, 180. So my instincts were to put a dot here to say that that was half a circle. That wasn't originally there, but it is half a circle because this is a right angle, so that has to be 180 degrees, which makes a semicircle or half a circle. All right, next example. We have angle T and R. Go ahead and label S and Q. And between S and Q, we have 66 degrees. And we have a point P over here. All right, the question is, find the measure of angle T and the measure of angle R. Well, angle T, if you follow T all the way down, you get to S and Q. That's the arc, 66. So the angle must be half of the arc, 33 for T. Well, if we follow these back to R has to be also the angle, the inscribed angle for 66, so it is also 33 degrees. All right, moving on. Sort of a little repetition of this from a different perspective. Example 2, or something like, oh, I think I repeated A. That's okay. Some more examples. Okay. Sorry, it takes a moment to draw these beautiful drawings here. So much easier when they're written out on overhead at school. Okay, so on this particular one, they have 180 degrees already given. So if this is 180 degrees, and we're looking for the measure of angle E, if this is 180 degrees, then we know that this is half of a circle, and therefore we know that angle E would be a right angle. Hopefully you looked at that and said, wow, she made that really complicated. Took a lot of time to draw it. We already knew that was going to be a right angle. Just watch out. If they don't have that point there, do not assume it is a diameter unless you have proof. This 180 proves that it is. Next one. What if we have a 74 degree angle and I am looking for the value of X here? X would it be twice as much or half as much? You're right, this is the smaller number. The larger number should be the arc. So 148 degrees. And then the last one in this section, sort of repeating, we've seen a couple of times what I call sort of the bow tie problem. Sometimes you'll even see the bow, it looks like a bow tie completed. We have an angle A and B that we're looking for. This is 40 between C and D. Well, the measure of angle A and the measure of angle B that we're looking for. Hopefully you notice the repetition because we did this one before. That if these are the angles, this is the arc, then the angles both open up to this arc. Therefore, they're each half as much, or 20. All right, so hopefully you're catching on to those. So let's jump up to a situation where there are more lines, because I wish I could say that this was it, but more lines will appear in the picture. For example, they could throw in a line here. They could throw in another line over here, or another line over here. And then your angles, the inscribed angles, would be disguised just a little bit, but they're still there. Just look for those 3 points on the circle that form the angles so you can follow the inscribed angle rules. All right, next one up. Again, I'm going to put a few extra lines here. I'll show you how we're still following our rules. Okay, so this particular problem says find A and find B. So let's just look at A and see what we've got. we have an arc A right here. If we follow that back from the points, we find that, hey, the angle that is 60 degrees, it is the angle that goes with that intercepted arc. So A degrees is 120, twice as much. No big deal, but there was just a line running across it, so it disguised it a little bit. Now, next, B. B does not open up to 120. B opens up to 120 plus a little bit more. Notice how this goes, yes, to P, but this chord goes to S. So what we have to do is we have to add the two of these up, which means that we have 150 degrees, 120 and 130 is 150 total for the arc. So B, the angle, is 75 degrees, half as much. Okay, so hopefully that made sense to you, so we can roll on to the next one. We're going to use this concept of adding arcs again really soon. Okay. Now, we've seen this concept already, but what if you get a picture and no degree measures given? And it looks like this. In circle O, what is the measure of angle A? No degree measure given. Well, what stands out? This diameter. So we don't need a degree measure because we know if that's a diameter, this half of the circle is 180, this half of the circle is 180. So this angle would be 90, open up to this 180 degree arc. There's our inscribed angle. So we've seen that about 3 times now, maybe 4. So hopefully you'll start catching on to those 90 degree angles because they're really helpful. Now, moving on to the next one. This one's a little bit more complicated. We have a quadrilateral. So now we're ready for multiple inscribed angles. A, D, B, and C over here. Now, first thing, do not assume that pictures are to scale. So just because something looks like an obtuse angle or an acute angle, don't assume that it naturally is. They're not out to deceive you, but a lot of times these pictures are generated over and over again. And when they change the numbers, they're not careful to make sure that the scale is correct. So I am not guaranteeing that the scale on this one is correct either. Now, what's given is this. 106, 100, and you can already see my 106 is looking a little bit smaller than my 100, right? Okay, and then, in fact, just so that I'm not being too deceptive, let's just move that B over a little bit. There, that should be just a little bit better. So I'm not being too deceptive. And we got 90 degrees here and 64. So we have a lot of arcs. Let's start with angle A. Angle A here. Well, angle A, its chord goes to B, and this chord goes to D. So the arc isn't just 100, it is 190. So if the arc is 190, the angle is half as much. So 50, 45, 95. Now, the good news is you don't have to add another set of arcs to get C, because C and A are supplementary. That was the corollary we just looked at. So if you take 180 degrees and you subtract 95 from it, you'll get 85. Now, a lot of you might be tempted to say, if this is 85, this is 85, but remember, this is not a parallelogram, okay? The only parallelogram where this works are for rectangles and a square being a rectangle. Rectangles will give you opposite angles that are both 90, and that's the only one where the opposite angles are going to be the same in a circle. Otherwise, they're just supplementary, which is completely counter to what we learned about parallelograms. So try to separate those two in your mind. Now, next one up, let's go back to our diagram. I'm going to get rid of the 190. And we're going to go to angle B because we still have two more angles to find. Angle B opens up to A and C. Well, where's the arc for that? That arc goes from A to C. So it is A to C, or 90 plus 64, 154. The angle, half of that, 77 degrees. Again, B and D are supplements. So 180 minus 77, 103. And now we have all four of those angles with those arcs given. Now, are they always going to give you all four arcs? No, but they'll give you some arcs, and you can work on whatever angle is possible to get based on the arcs that they do give you. Just remember, if you have a quadrilateral, you're going to have to do some adding together. All right, let's look at a few other pictures. Let's do another one where we have a quadrilateral, and it's going to be just a touch different. In fact, we're on example 3, and I'm actually going to be first. Since we're working on a quadrilateral, I'm just going to be consistent and keep working with that. There's the center of our circle. Excuse me. Close enough. I wasn't aiming for anything that looked like a rectangle. It's rectangle-ish, but that's okay. So we have angle 1, angle 2 over here, angle 4 over here, and angle 3. And we've got 60 and 80. Angle 2 is the whole angle. Angle 2 is the whole angle here. They just have a dotted line going through them. And the dotted line is representing a diameter, which is really important. Because if we have a diameter, that means this half of the circle is 180 degrees. This half of the circle is 180. So that means at the top, if this is 60, this has to be 120. And if this is 180, 180 minus 80 is 100. And again, is this to scale? No. This should be a lot shorter than this. And these almost look identical. So my scale here is a little wonky, a little off. But again, as I said, do not assume it's to scale because you get caught sometimes where it's not. Now, hopefully you've recognized that angle 1 and angle 3 have to be 90. You're like, what? How am I supposed to know that? Well, if this is our diameter, angles that open up to a diameter are 180 degrees are automatically half or 90. And they're also supplementary. They do add up to 180. All right, looking at 2. Angle 2, its arc goes from this angle all the way over here to this one. So all together, the arc for angle 2 is 100 plus 120, or 220. So the angle is 110. And that's the whole angle here, not the top or bottom half. Ignore the dashed line. Now, angle 4, here is the arc for that one, going the other half of the circle. 80 and 60 is 140. So that would be 70. Well, we knew that was going to happen because if this is 110 and these are supplements, 180 minus 110 is 70 for this entire angle as well. So that's just another example of the quadrilateral inscribed in a circle and all of its inscribed angles. They just had some 90-degree angles in there. Now, it is possible, and I'm just throwing this aside, this is not in the notes, it is possible to have 4 90-degree angles for an angle inscribed in a circle, and that would be a situation where we have a rectangle, which this one looks like a square. It very well might be, but we'll just say rectangle because we know a rectangle is a square. Okay, a square is a rectangle, excuse me. A square is a rectangle. So whether this is a square or not, it is certainly a rectangle with 4 right angles, and the opposite angles are also supplementary. A parallelogram, a rhombus, they would not actually hit, all 4 points would not hit the circle, so it would not be inscribed, so it wouldn't apply in this theorem. All right, walking back to another example. Let's go to 2 more, and then we'll talk about one more theorem in this section. All right, so the question is find the numbered angle. So find the missing angle 1. Hopefully you were not distracted by the fact that I threw an extra line in here. I threw a 40 in. That 40 would give us a 20-degree angle here, but that wasn't asked for. This 70-degree angle would give us a 35-degree angle here, but that also wasn't asked for. Just thought I'd throw that in for lanyard. But what they are asking is what's angle 1? Here's our diameter again. So angle 1 would be 90. All right, another problem. It looks sort of like that bow tie problem. Yes, it is. All right. Let's do something like this. We've got 38 degrees here, 70 degrees here. Again, don't kill me for the scale. It's going to be a little off. So now they're asking to find angle 2, that angle up at the top. Well, what we do know is that if this is 38, then the arc over here that it opens up to would be 76 degrees. Well, angle 2 opens up to the same arc, so it would also be 38 degrees because it opens up to the same one. You're like, well, what about that 70-degree angle? What does it go to? It doesn't go to anything. In fact, it doesn't even go to this angle because it's not a central angle either. Remember, central angles would have their vertex at the center, and none of the angles that we have had in this section have their vertex at the center. So what's going to happen when you do the practice and you're getting to a test, you'll have central angles and inscribed angles in the same assignment. So you really have to look at your notes, watch and make sure that you're not getting your signals crossed. Now, one final theorem in this section. It's not an inscribed angle because it doesn't follow the definition, but it acts like an inscribed angle. So that's what we're going to look at right now. This angle is actually formed by a chord and a tangent, chord and a tangent. This angle here does have the intercepted arc that goes all the way to the vertex. So it's kind of strange because it ends at the vertex, whereas the others end at the 2 arcs, angle arcs. The ends of the arcs end at the rays or the chords, the segments that cut it. Now, the rule is very much like an inscribed angle, the angle is half of the arc. So if we had C, D, B, the measure of angle C is equal to half of the measure of arc BDC. So let's put that into practice. I almost missed, but I made it. So we're asked to find angle 1 and 2. What we're given over here is that from P to M to Q, all the way around here, PMQ is equal to 212. So if this arc is 212, then angle 2 would be half of that, or 106. We also have to find angle 1. Some of you might have said, well, if this is 360 degrees, can I subtract 212 from 360 degrees? Sure. And you get 148. Let me double check my math. 360, yes. And then this would be half as much. Sure. If you did do 360 minus 212 and you got the arc over here for 74, that would be half of this arc. The other thing you can do is just use the good old linear pair. If you've got one of these, the other one is 180 minus the first one. And so angle 1 is equal to 74. All right, let's do one more problem and wrap it up. And I'm going to show you a slightly more complicated problem, just simply because they put a lot more lines in it. And this will be the last one for this section. Let's stick with it. The hardest ones always last, or at least most of the time it is. Okay, try that a little bit longer. If you're following along in the notes, this will probably look slightly different. My drawing is just a little off, but it's going to work for this problem. That's 35 degrees. This is Y. And this angle in here, I'm kind of coloring it in. This angle in here is X. And we're looking for X and Y. So this is what the instructions say, since you can't read them. I'll read it to you. In the diagram at the right, KJ is a tangent. Okay. In fact, this was not given, so let me leave that out. All right, so it's KJ is a tangent to circle O. We're looking for the values of X and Y. The inscribed angle, angle Q, and the angle formed by a tangent and a chord, KJL, the intersect the same arc. Okay, so they are talking about the fact that this angle has this arc in here, and that angle this angle in here, X, has the same arc. But I'm going to approach it from a couple of different possibilities. First, I have a 90-degree angle. You might have seen me draw it in and then take it out because it wasn't there originally. That's a 90-degree angle because this is a diameter. So Y is pretty easy to get because 3 angles add up to 180, or these two would be complementary because that's 90. So the other two together have to be 90. 90 minus 35 is 55. So if Y is 55, this arc here is 110. That's the arc for this, which tells me that this angle over here is 55 as well, because it's the same as that tangent and the arc. The angle is half of the arc. So this is my arc, this is my angle. Well, the reason why that is important is because 55, 90, and this angle, they add up to 180. if they add up to 180 and you subtract 90 and 55 from 180, x is 35. Okay, so that kind of goes back to the little hint that I read at the beginning. It might have kind of gone over your head because it's really hard to just have somebody read it to you instead of reading it yourself. But what it was saying is this angle has this arc right here. And this angle formed by this chord and this tangent, that has the same arc. This arc is 70 degrees. Double this, 70 degrees. This angle, x, that we're working on, it is half of that arc as well. Sometimes it's hard to see that because it's so skinny in there that it's harder to tell what's going on. Okay, so I gave you two alternate ways to find that angle. All right, so now you could do section 12.3. Watch for those inscribed angles. Remember, the angle is always the small one. The arc is always twice as much. Have a great day.